Hello, everyone. Welcome to the Math 95 graphing. We're going to talk about graphing lines both in 95 and in 96 this week. So we're just going to go through these problems. They are paper homework assignments, so good luck. And lots of different types of questions. So we're going to be bouncing around from one to the other. And we're going to start by looking at number 3 and 4 in this first section. Plot the following points and say what quadrant or axis they're in or on, and label using 1 to 5. So number 3 is the point -4, -3. Remember, that's the, whoa, I don't know how to write the letter X out of all letters. The first one's the X coordinate and the second one's the Y coordinate. This is the X axis. This is the Y axis. So -4 means we count 1, 2, 3, 4 to the left. -3 means we count 1, 2, 3 down. And that brings us to our point. -4, -3 is 4 left. Wait. 4 left is one over, one more to the left. 4 left and 3 down. And then we label this as number 3, just like it tells us to. Okay. So that's what we do. And we answer this is in what quadrant? Well, this is first quadrant, second quadrant, third quadrant, and fourth quadrant. We use Roman numerals for these quadrants. So it's, of course, in the fourth quadrant. This is one of those points where I ask myself, should I restart the video? I've messed up the letter X. I've messed up counting to 4. I've messed up counting to 3. This is, of course, in the third quadrant. Phew. All right, and now we do problem number 4, which says, look at this point, -3, 0. That is 3 left, 1 left, 2 left, 3 left, and 0 up or down. This is problem number 4, and that's where it is. It's not in any quadrant. It's on the x-axis. Okay, it's between the second and the third quadrant, but it is not part of it. All right. Next up, I want to look at number 10. Give the coordinates of, wait, we just did that. It's the same point. Let's do number 8. All right. What is this one? Well, we just count. 1, 2, 3, 4 to the right, and 1 down. So 4 to the right, right means positive. 1 down, down means negative. This is the point 4, -1. Complete the ordered pairs. So if we know we have a line is just all the points that satisfy this equation, all the points that make this equation true. So if we know, for example, that the y coordinate is 3, we need to find out what the x coordinate is. We know that -3x plus 5y equals 10. Any point on the line, this is true. So if y equals 3, we can just plug it in. Y equals 3, they are the same thing. Equals means the same. So this becomes -3 times some x plus 5 times 3. Y is 3. It's the same equation, just instead of a y, instead of 5 times y, it's 5 times 3. And now we can simplify and then solve, just like we did in the previous units. 5 times 3 is 15. We need to get x by itself, so we subtract 15 to both sides. Becomes 3x. This cancels out. 10 minus 15 is -5. Divide both sides by -3. Again, it will cancel out. You should get x is, the negatives cancel, so x is 5/3 as our answer. And in fact, a lot of these, you can sort of check your answer. Hold on, let's see if I can improvise this. A lot of these, you can check your answer with something like Desmos, right? Or a graphing calculator, something like this. We know the equation is -3x plus 5y equals 10. We're using, we'll be using Desmos more as the quarter goes on. So hopefully, When the y coordinate is 3, the x coordinate is 5/3. Let's look at that. When the y coordinate is 3, look at the y coordinate. Is 1.68 5/3? Oh, it is. One of the things we'll talk about later in this quarter as well is intersections. Y equals 3 is a horizontal line. We'll talk more about that in these videos, in the next videos. And their intersection also has that x coordinate. But we talk more about systems of equations and intersection later on. My neighbor is obsessed with his leaf blower. It's every other day. It's got to be every other day, maybe every day, every single day. I don't know anybody needs to leaf blow that much. Anyway, hold it together, Jason. Let's look at one of these from number 12 too. So I kind of said number 12 earlier. What ordered pairs are solutions? Solution just means makes the equation true. Okay. So anytime you see solution to an equation, solution to an inequality, that just means it makes it true. So if we look at this guy, for example, we're going to have to check all of them. But I'm not doing all of the homework, just some of the parts. You'll have to check this for every single one, but let's just check this third one. 4, 2. So that's x equals 4 and y equals 2. Does that make this true? 2 times x, which is 4, plus 5 times y, which is 2, equals -2. And again, you can notice that over here, there's a lot of different ways of writing multiplication. 5 times y, 5 times 3, 5 times 2. That's all multiplication, but we're writing it 3 different ways. And that's okay. So is this true? I'll put a little question mark over that equal sign because we're wondering whether it's true. 2 times 4 is 8. 5 times 2 is 10. Is that equal to -2? Nope. If 10 were negative, it would be, but it's not. So this is not equal. 18 is not equal to -2. So this is 4/2 is not a solution. And you could do the same process with the other 3 ordered pairs. For the next group, we're just doing some matching. I'm going to do number 13 and number 15. So we need to match the x-intercept and the y-intercept to the equation on the left. So the easiest way to do this is to just find the x and y-intercept. I think if you check every single one of these, it's going to take forever. If you just find it, then you can just pick the right option. So remember that the x-intercept is where it crosses the x-axis. Crosses the x-axis, that means y equals 0. Y-intercept is when it crosses the x-axis. That's where x equals 0. So for this first guy, what happens when x equals 0 and what happens when y equals 0? That gives us our answer. Don't have too much room here. Who made this homework assignment? All right, so we're going to go off to the side and say, all right, our equation's 3x minus 4y equals 12. Let's find the x and y intercept. So x-intercept is when y equals 0. So 3x minus 4 times 0 equals 12. 4 times 0 is 0. Divide both sides by 3. The left side will cancel out. We're just solving equations like we did before. We get x equals 12 divided by 3 or 4. Okay, so the x-intercept is the point 4, 0. And now we do the same thing for the y-intercept. The y-intercept is where it crosses the... Whoa. The y-intercept is where it crosses the y-axis. Which is when x equals 0. So we do the same thing, except this time you can see it. So 3 times x, which is 0, minus 4 times y, which we don't know, equals 12. So we get 0 minus 4y. Be very careful. The minus stays with the 4. And divide both sides by negative 4. On the left side, they cancel out, and we're just left with y equals 12 divided by negative 4. Positive and a negative, multiplied or divided, makes a negative. We get negative 3 over here. So the y-intercept is the point 0, negative 3. So we found the x-intercepts. We found the y-intercept. There's only one of each here because it's a line. And we can go tab over. Make sure everything is showing the right thing. X-intercept is 4. So there's a couple options. Oh, wait, there's only one option, right? This is the only one that has an x-intercept of 4. And it has a y-intercept of negative 3, just like we wanted. And again, there's different ways of writing this. So our answer is going to be C. This is one way of writing the answer. This is another way of writing an answer. Or just more briefly. And they're showing you different ways of writing these answers here. All right. Okay, so we could do the same thing for number 15. Number 15 is the equation y equals negative 5. The x-intercept is when y equals 0. So when y equals 0, substitute that in. Solve for x. There is no x. I can't solve for x. This is never true. Solutions to an equation are just all the x's and y's that make it true. Well, this is never true. This is never going to happen. There's no solution. But what does that mean for our x-intercept? It can't happen. It doesn't exist. All right, and we move on. The y-intercept is when x equals 0. Well, replace all the x's with 0, and what do you get? This. There are no x's to replace. Okay? If you replace all the x's with 0, this is what you get. Nothing changes, and we still find our y-intercept. Y-intercept is 5, negative 5. So the point 0, negative 5 is our answer. X-intercept doesn't exist. Y-intercept is negative 5. And this should make sense if you're really good with your lines. This is just the horizontal line, y equals negative 5. It never crosses the x-axis. Where does it cross the y-axis? Right down here, when y is negative 5. Okay, so it does not exist. And negative 5 are our answers here. If I can find my sheet. Does not exist is right here. And negative 5, it matches, and that's letter F. Hooray. All right, 2 more problems. Let's do 20 and 21. Graph the following equations, plot points, and draw a line using a straight edge. Yeah. X equals negative 3. The graph of a line is all the points that make it true. What are all the points where x equals negative 3? What does y have to be? We don't care. There's nothing here that has to do with y. X is negative 3, and y is anything, right? Y isn't mentioned here. So every point where x is negative 3, and y can be anything. Y can be 1, y can be 2, y can be 3. As long as x equals negative 3, the vertical line. All the points where x equals negative 3, doesn't matter what y is, this equation's still true. Any point on this line makes the equation true. Pick a point. This is the point negative 3, negative 2. Is that on the line? Well, if we plug it in, we get negative 3 equals negative 3. Yep, that's true. You can see that y didn't matter at all. And that's why any y will do as long as the x is -3. 21 similar. There's a couple different ways of doing this. You could put this into slope-intercept form. Y equals mx plus b. Some people like to do that. Solve for y. We've done that with 96 stuff. Solve for y in a formula. That's one of the advantages to it. Some more learning actually coming to help us. Okay, or you could just plug in some points. That works too. You could make a table. Let's make a table of x's and y's. If x is 0, what does y have to be? That's exactly what we did over here. So multiple ways of doing this problem. This is one. Well, if x is 0, what does y have to be? Well, we get 0 minus 3y equals 5. Negative 3y equals 5. Divide both sides by -3. You should get y as -5/3. That's about that's -1 2/3. If we're graphing it. So x is 0, y is -1 2/3. About here. And you could keep on doing this. Choose more points, 1, 2, 3, 4, and just put the y coordinates and plot it. Or if you put this in a slope-intercept form, because again, I said there's 2 ways of doing this. There are more, but 2 is one. There are at least 2. We could subtract an x from both sides. I'm not doing 22. I'm just doing 21. So if we look at this guy and subtract an x from both sides, what happens? We get -3y equals -x, and the 5 is positive. Subtract an x from both sides, this is what you get. Divide both sides by -3. The left-hand side becomes y. The right-hand side is a little bit more complicated. We can divide each of these by -3. If the addition is in the denominator, this doesn't work. But addition in the numerator, it does work. So we get positive x over 3 minus 5 over 3. In the first one, the negatives cancel. In the second one, there's still a negative. Or we could write this as 1/3 x minus 5/3. And you can still get that 5/3 as the y-intercept. Remember, slope-intercept form, y equals mx plus b. M is the slope, and b is the y-intercept. So you can see the same y-intercept that we found earlier. And we know the slope is 1/3, which means we go up 1 and right 3. Up 1 and right 3. Or you could go back to the start and go down 1, left 3. Down 1, left 3, and so on. And you should get a bunch of points that are in a line. You get this as your answer. Let me know if you have any questions, and that's it for this video. Remember that you can see the full video. This is just kind of review. We go through these topics quickly, hopefully just refresh your memory and work through some problems, give you some examples. But remember, there's full lectures as well in the same module. So check it out in the module if you want more of this. You can also ask me questions. Good luck and have a good one.